Okay. Yeah. Okay. That's beautiful. So you guys, so let's call on the first instructor for today by the person of Trevor. Yes, he's a GitHub Campus expert. He's going to be starting this workshop on branching and merging, you guys. So stay tuned. Please be very attentive. And if you have any questions, if it's not urgent, just put it in the comment box. But if it's urgent, raise your hand, right? So it can be either of those ones. Yeah. Okay, so Trevor, over to you.
Hello. Thank you very much, Victoria. I hope you guys can hear me.
Yes, we can.
Yes,
Okay,
we can.
cool. Great. Let me just get my slides ready. So yeah, in case you can't hear me or in case of internet interruptions, just feel free to interrupt me and let me know that, hey, Trevor, we can't hear you. Check internet connection. So stuff like that. So in this call, we have two instructors. That's me and Alex. We're both GitHub Campus experts. And basically, I'm going to be focusing on showing you the basics of branches in Git and merging. So while I'm presenting the slides and running the commands, if anyone has questions, you don't have to wait for me to ask for the questions. Feel free to raise those questions in the chat, and then my co-instructor Alex will give you answers. So you get them like in real time. Or if it's a really burning question, I'll also like have like a few pauses during my presentation to ask for questions that you'd like to share. Yeah, thank you again. I'd like to start by introducing myself. Like I said before, my name is Kato Trevor Thomas. I'm a GitHub campus expert at Makerere University. That's all the way from Uganda. I'm actually there right now. I'll be graduating next year. Yeah, I'll be done with that part of life, education. And then I'm also a software engineer at Airtech Limited. It's a fintech startup that deals with payment services and also KYC and KYB services. And yeah, it's a pretty interesting field to be in. I've also been part of the Google developer groups on campus community. I was an alumni. I was the lead in 2023, 2024 cohort. It was a great experience, and I like music, just like everyone else does. So I don't even know how I did that, but yeah, that's about me. I'm sure Alex will introduce himself on his session. So again, like I said, I'll just be introducing you guys to branches and the different concepts, like the basics of branches. And then Alex will get into more details regarding branches. So yeah, branches are very interesting. Again, you guys can hear me, right? I'm assuming since no one has said anything, you guys can hear me. So I'm going to keep on talking. Yeah, I'll try not to be, I'll try not to over talk. I'll make sure to do. I actually have my VS Code open. Yeah, we're going to do some actual learning here and get some stuff done. So can't wait for that. I'm excited for this. Yeah, so again, in case I'm too fast, feel free to slow me down and interrupt me so that I can reiterate on some things. So branches. Now a branch, again, GitHub is a way for you to collaborate with other people, but on the same project. That's how I like think about it. That's like one of the biggest benefits with Git and GitHub. And the concept of branches, a branch refers to your own your own development flow. Like for example, here, as you can see in the image here, so the main repository has its own branch, right? That's the master branch, right? But now, in order for you to be able to like make changes or collaborate, if let's say you're working on a team of about 3 people, right? So you have the master branch, which is like the source of truth in this case. Like it has the code that if someone asks for it to be deployed or asks for it to be like ran, that's your go-to. The master branch is like the main branch. It's the source of truth, right? It's the main source of truth. And then let's say you want to add like a feature, or you want to fix a bug, or just basic enhancements in terms of performance and all that. And you want to add changes to the code base, right? So you make your own branch, your own I would say your own development timeline. You make the changes. Well, each of these round things here are actually commits. I believe this was talked about in the previous session yesterday. Commits are just saved changes, right, to your branch. So you make your branch, you make your changes, you save them, and then you merge them to the main branch. Yeah, and then at this point, you have a commit added to that main branch. So again, if in case you don't get some concepts today, it's expected. Most of these things, especially if they're new, you don't get them on the first day. Even I didn't get branches on the first day. But the biggest or the best way to get to really learn and be familiar with these concepts is by actually doing. So yeah, I would recommend doing. It's very helpful. Like just getting your hands dirty, it really helps a lot. You get to understand things like in real time. So one mental model, or just one way that I try to understand branches is I don't know if I'm the only, if anyone here has watched Loki. I think we're in season 2 now, Loki, or even just the Marvel universe, right? So you have this concept of the multiverse, right? And basically that's you having like different branches or different timelines. And actually, I like the concept they use in Loki. They call them branches because they are in our branches, right? So you have the main timeline, in this case, the master branch, where all events are as expected, right? But let's say something happens and a branch is created from the main timeline. So now I have a different timeline or a branch in this case. And in each timeline, we have events that occur. So an event, in the case of Git, it's like a commit, right? It's a save change. There are significant events that happen. And the beauty with this is that these events happen independently, right? So you have an event happening in this branch, event or commit happening in this branch, in your branch, where also other events happening in this branch, the main branch, right? So we are having different branches or timelines there, and they are, say, they're happening, and they consist of events that are happening independently, right? And the good thing that comes from that is the fact that we can have collaboration. Different people can work on the same repository or the same source code without having to be interrupted, because now I'm doing my work on my branch without touching the main branch. I just have my own work on my branch, and then someone else's work is being done on their own branch. And at the end of the day, we merge those changes and we're able to work on different things at the same time, right? For example, I could work on like the login feature, but someone else works on the sign up feature, right? Although those are very similar things, but you get my point, right? So different people can work on different features for the same project simultaneously. We don't have to wait for one person to make changes, then the other person comes in after. That's the beauty about branches. It allows simultaneous development among different people. So the goal for this session is, I made sure to talk about the importance of branches, right? It allows you to work in your own timeline, right? Without being affected or without affecting the main branch, right? And it also allows you to collaborate with other people. Like I said before, I can have my own feature branch for adding login functionality to, let's say, an application. Then someone else can have their own branch to create like the home page of the same application. right? So we have one person working on the homepage and working on the login functionality, and they're doing different things at the same time. So we don't really have to wait for the other, which makes things a lot faster. It's also a safe space for experiments, right? So let's say I want to use a new library or like make an update to an existing library. I can make a branch of main and then make those updates in terms of the dependencies and then see the outcome, right? If it fails, I'm fine because I haven't affected the main branch. I've only those failures are only on this branch of mine, which I can just ignore and move back to the main branch, right? Another thing is the main branch stays stable because the main branch, again, like I said, if you tell me go back to this slide, the main branch or the master branch. I hope no one gets confused by that. So main is the same as master. It's just your source of truth, right? It's the branch that has working code. It's a branch that has code that you're sure is going to work. Like in most cases, the master branch is like can I say like the holy grail? Like it should not be like tampered with too much. That's why you're allowed to just make your branch outside of master or main, make your changes, see if they're working or not. And once you're sure they're working, then you can merge them into master. Yes, so that is why branches matter. Uh, Before I go on, are there any questions? And if there are any questions, please feel free to just mention them because I can't really see if people are putting up their hands. So, yeah. Okay, so I've had the silence, so I'm assuming that there are no questions. So I'll move on to the second bit of the session. Yeah, so we're now going to try to do this hands-on. It would be nice to have other people doing this too at the same time, but feel free to also do this outside of this call. The good thing is this session is being recorded, so you can follow up on this. And also there are a number of YouTube videos and a number of resources on the internet that can allow you to do this stuff at your own time. So that's the beauty about the internet. You can do this at your own time, at your own pace. So yeah, feel free to do this even outside of this call. So what I'm going to do now is I'm going to try to create a branch. So I hope you guys can see my VS Code. And right now I am currently, just to show you what I did at first. This is a lot of stuff. Okay, so let's just focus on this command here. So there's a repo that was created yesterday during yesterday's session regarding GitHub basics, right? I'm sure they showed you the basic Git flow. So I cloned that repository. Actually, at first so I cloned the repository and now I have a local copy of that repository on my computer. And I now have it here on my computer and I'm in the master branch. So the first thing you want to do is you want to see which branch you own. You want to see your current branch, the branch that you own. And so you run git branch. And so you run the command git branch. Now, again, there are a number of commands that are done. So you have two options on how you use Git. You can either install the GitHub application or the GitHub web application, then you can run these, you can perform these actions with the user interface, just buttons doing this and that, doing the same thing. Or you can decide to use the command line interface, which I'm going to do for this session. So for me, personally, I prefer the command line interface because I feel like I'm in control. I don't know, even though there's really not much of a difference, but I feel like I'm in control and I'm actually understanding what's like happening, like underneath, right? I'm understanding what's like going on. So for my advice is if you want to like get familiar with Git, you could start with the command line interface to just understand what's going on and then move on to the user interface, right? Where you just click buttons to perform the actions. But at least in that case, you know what's going on. So yeah. So as you can see here, so I just made the git branch command. I run it, and according to this, I'm on the master branch. So how I know I'm on the master branch is that okay, it's easier for you to tell when you have different branches. So first I'm going to do is I'm going to create another branch, right? So for according to the slides, creating a branch, I just say git branch along with the name of the branch, right? So I'm going to create a branch, a new branch. I'm going to say git branch, test branch 1, right? So after creating a new branch, then I'm going to run this, the first command that I did, git branch, to see which branch I'm currently on. So yeah, so we now have two branches, right? We have the master branch and the test branch, right? As you can see, the master branch is highlighted, meaning that that's the branch which I'm currently on. So right now I'm on the main timeline. If you look back at the reference for the Marvel Universe, oh, okay, I'm in the main timeline right now. I'm like in the red. I mean, like in the main source of truth, right? But now I want to do some funny stuff. Like I want to add a new feature. I want to make a bug fix, or I want to test, or I want to make enhancements to a certain file or dependency or library. So if I want to do such risky stuff, I rather not do it on master. I rather do it on the test branch, right? On this other timeline, in my own timeline, right? And do my own thing without affecting anyone else, right? So now I'm going to move into the test branch. And the way I do that is by running git switch. Git switch, you're moving from one branch to another. So I say git switch, and then I specify the name of that branch. Again, the branch that we just created, that's test branch 1. And yeah, according to the output, it says, again, I hope you guys can see my command line. I could make it bigger, but I feel like this is visible enough. So yeah, just interrupt me in case anything is not clear. Fine with that. So yeah, so now we have moved into the test branch. And I think that helps you know which branch you own is, okay, so I'm using git bash as my command line interface in VS Code. I just like the colors. I mean, you have other options. You can use PowerShell. You can use PowerShell or the command prompt, but I prefer Git Bash because I just like the colors. I like colorful things. So yeah, so we're now, I can just run Git branch again. We're now in the test branch 1. So now I'm on my own branch that I can make my own changes and see the outcome of those changes. So the first thing I'm going to do is I'm going to come here and see the files. We're seeing this file. This was done yesterday. I can even see here by the instructor from yesterday's speech. And I can actually, yeah, I can open this in the browser to see how it looks. Let me open it in the browser, the HTML. Okay, open that. Yeah, so there's nothing, honestly, because the body was not defined. So I'm just going to add some basic text to it. Just hold on a minute. I'm going to add p. Hello. This is my first branch. Yeah, so I've now added a paragraph tag, and I expect to see it on the browser. Just need to refresh this. And yeah, there it is. So I've just added my change, right? I've added my own paragraph to the same file. So coming back to VS Code, as you can see, so I'm using VS Code, like I said, and I'm very familiar with VS Code, and I like the way it shows Git changes. So you can see here, I've made a change. It shows here from these highlights, it shows you the changed lines. When I open this source control part of VS Code, I can see, let me just make this a bit wider. So I can see that I've added this paragraph tag. I've added hello, this is my branch. And it shows you, so on the left, we have how it looked before. And on the right, we see how it looks now. Yeah. So I'm going to come back here. So one way you can see the files that have been changed on your branch, you can run git status short. I add the short flag so that I get the concise, brief information, right? You can run git status, but it shows you more information, right? It shows you the modified file, also along with other information about you, about the status of your repository. So I run git status short so that I can see which file, the exact files that have been changed. So yeah, I've made a change to index.html. and I would like to commit those changes and see what happens next, right? So I'm going to commit those changes on my branch. Again, we are still on my branch, that is branch 1. So I'm going to, first of all, stage the changes. I hope we talked about this yesterday. Staging is just basically you saying that these changes are ready to be committed, right? Like you're staging them like they're ready to be saved to your branch. So I've staged them. If I run git start ashoot again, it shows that I've staged them because it's green. Before it was red. I could show you that. Before it was red, but it's now green because the changes have been staged. So might be first. I might make a commit. Yeah, to make a commit, git commit. A commit is again you saving those changes, and you can add a message to that change for understandability. Let's say someone else wants to see what you've done, they can read. The first thing they do is read the commit message, so they see and get to know the change that you've made. So I'm going to give this commit an understandable message, so that someone can need to understand what is actually a change. So I'm going to be like added paragraph tag. That's a commit message that I've made. And yeah, so I've made a commit to my branch. So now, actually, one thing that I like about VS Code is that it shows you there's this feature. Is someone talking?
Who's the person? Mute your mic. Come. Please mute your mic.
Yeah. Uncle, this for you, brother. I'll eat some with mommy.
Just continue to count me during the back.
It's hard to continue. Have they muted them? Can they mute or something?
See, that's the one that will live.
This one no phone. Send this one to that.
Ooh.
She wants something like this.
Brainy Bentham.
That is sweet.
Or is it Brainy? Brainy? Could you mute?
Okay,
Thank
I've
you.
muted the person. Yeah.
Okay, cool. So before I get back, I hope we're on the same page. Can I have like reactions or something? Are you learning something? If you're not, at least you're paying attention. You know, I'm trying my best here, but just know you can also learn outside of this call, so no worries. Okay, cool. So back to the command line interface. Yeah, so as I said before, we committed this change to this branch which I am on. And so now what I'm going to do is I'm going to try to merge this branch. So let's just come back to the slides. Ooh, sorry about that. Yeah, so we created the branch. We have seen how to list all the branches so that we can see the current branch. We have seen how to move to a branch, right, from the current branch. Or this is also another option of how you can create and then switch to a different branch. So I can do that too. I can go back to main, right? Git switch master, or in this case it's master. Git switch master. So right now, if I run git branch, I'm currently in the main timeline, right? In master. So I want to try to create a new branch and also switch to that new branch at the same time, right? And the way I would do that is I would say git switch C, add the C flag for you to create that new branch. And I'm going to call the new branch test branch 2. Forgive me, I am not creative with names. Like almost even commit messages, it's a full-time job for me, like to really get a meaningful message to give a commit and even a branch. Like that is like it's so hard, but yeah, you take the time, you understand the goal, then you give it a meaningful name. So yeah, right now I'm in the test branch 2, which I just created just for you to see that you can create and then switch to that branch at the same time. So I'm going to go back to master by running git switch master, and then I'm going to try to merge. So merging is where you, if I could go back here to my slides, it's a very nice picture here. So yeah, so now we are at this point, right? So what I've done, what we did at first is we created a new branch called test branch 1. I made my changes and then I saved those changes, right? I made those commits to that branch, and now I want to merge those changes to the main branch, right? Again, if I go back to the context of Marvel, which I like a lot, anyway, let me not get too nerdy, but if I go back to the context of Marvel, I have gone out of the main timeline into my own timeline, right? A number of events have happened in that timeline of mine, but in this case, commits, or in this case, they're commits. These are changes that I have saved in my timeline. And now I want to merge my timeline to the main timeline. Now, unlike in real life, whereby if you merge a timeline to like the main timeline, you'll have a lot of chaos, and some people might perish or just disappear from existence. In this case, things are well sorted and catered for. In this case, I'm simply merging my changes on a specific file on a specific line into the main repository or the main timeline in an organized manner, right? Now, that chaos bit of things comes in when you have conflicts. These are things that are going to be talked about by my co-instructor, Alex, where you have where you're trying to merge two different timeline or branches. You're trying to merge them, and they have different changes on the same line in the same file. So at that point, Git does not know what the source of truth is. Again, my co-instructor will talk more about this, but yeah, that's where stuff gets chaotic. But it can also be handled very easily. So yeah, I'm going to try to merge my branch, the test branch, to master. Again, you can do these things either from the UI on GitHub, or you can do it on or you can do it on the CLI on the command line interface. But me, I just prefer to do it on the command line interface because I feel like I'm in control. It feels cool. I just do it. But you can also go ahead with the option of doing everything on GitHub and clicking buttons. So yeah, right now I'm on the master branch. So what I'm going to do is I'm going to say git merge test branch 1. So let's remember that test branch 1 is a branch that I created at first, right? I added my changes and I committed them. So events happen there, and I want to merge them to the main branch. So I say git branch. I say git merge this, right? So yeah, so now I've merged it, and a very cool thing that we see here. Okay, so this kind of looks complicated, but if you like have an idea of the concept of branches, it actually looks cool, especially because of the colors. So we see here it shows me that I'm on the master branch, right? I'm on the master branch, but I've also just merged the, I don't know, it didn't look as good. Okay, so the way it works is, so right now I'm on this commit, the added paragraph tag commit, one that we made before. So I merged that change to main or to master, and it's showing me, so these are commits that were made before. This was the initial commit made by yesterday's instructor. He added all these, the git ignore and the box. So I've merged the change that we made on test branch 1. I've merged it to master, and now it applies here in this case. The concept of branches, I like to explain it while drawing diagrams, but it's hard to do that online, especially when you don't have like a touchscreen laptop, which I do not, sadly. But yeah, I'm working with what I have. So yeah, so we have now managed to merge this new branch that we made to master. If I come back here to the slides, yeah, we talked about this, we talked about that, the mergers. Yeah. So yeah, again, when you try to merge, like I mentioned before, you can reach a point where you have conflicts. But this is something that can be done by my next co-instructor. I'd like to show you guys one option. One option of merging. So for example, right now, as I said, if I do git branch, I'm on the master branch, right? So I'm going to switch to the second branch that I created, git switch test branch to. Wait, sorry about that typo. Yeah, git switch test branch to. And git branch to check the branch I'm on. So I'm in that branch, and then I'm going to make a change. What change am I going to make? I'm going to just make a change to the title. Yes, I've made a change to the title. I'm going to then commit that change and show you guys the option that you have to run all this stuff from the user interface, right? So we did the CLI, but now I'm going to show you from the UI. I'm using VS Code. Different IDEs or different text editors have different ways of making this work. But anyway, I'm going to run CLI for the commit, then show you how to merge from GitHub, from the UI, right? Okay, so I've made the change. First thing I need to do is stage the change. I say git add index.html. I want to stage the changes in that file. I've staged them, and then I commit them. Git commit. I have my commit message. Add a new title. I made the commit message. I've committed, and now I want to merge this test branch to master. So this brings in the topic of local branches and remote branches. And a local branch is a branch that you have on your computer, while the remote branch is a branch that is like it's on GitHub, right? So it can be accessed from any other computer since it's like in the cloud. Like you practically uploaded it. So I'm going to upload this branch to the remote repository. I'm going to just say git push. Git push is what you do when you're like pushing the changes. You're like uploading them to the cloud, to GitHub. I'm going to say git push git push branch. So yeah, I'm pushing the changes. The U flag is me saying that I want to make these changes on the upstream branch. I want to sync these changes and create a branch upwards, I would say, like to a remote branch. So I've run the command and the new branch has been created. So I'm just going to go to that repository real quick. Yeah, so so I come here to the repository and we have two branches, right? I don't know if you guys can see this. Is it just me? Is it the fact that I'm using dark mode? Yes, that I'm using dark mode. Anyway, so we have two branches, right? The master branch, the one that's the remote branch, and the one that I've just created here, the test branch too. So I would like to merge this branch to the master branch. So what we did before can be done online. The first thing you have to do is make a pull requests, which is another concept. Either they're going to introduce this tomorrow or they introduced this yesterday. But basically, a pull request is just you asking to have your changes merged to like in this case to the master branch, right? So I want to move my changes to the branch, right? Add a new title. It's a commit. Create a pull request. This is a bit too much. I feel bad. Guys, forgive me for overshowing too much information, but I was just showing you that you have the option of doing this even with the UI, right? So yeah, I make the pull request and I have it matched to main. Again, pull request, somewhere to be looked at either tomorrow or it was looked at before. But that's it for my presentation. I'm now going to open the floor to any questions regarding branches before my colleague comes in. I'll make sure to share a link to the slides that I was using. They're actually like at most 5 slides, but in case you want to follow up, I'll make sure to share a link to those slides in the chat. Also, in case you're interested in learning this even beyond this call, feel free to just type Git branches like in the internet, and you'll just see a number of resources that will help you to learn about Git. So I see someone's hand is up. Yes, Hofer. I don't know if I'm pronouncing that well.
Hello, can you hear me?
Yes, I can hear you.
Okay. Good evening, everyone. Good evening, sir. Yeah.
Good evening,
My
Hofer.
question goes like this. What's the difference between Git clone and Git branch? What's the difference between the two, Git clone and Git branch?
Okay. Good question, Hofer. So the best way I can answer your question is by doing it manually. So I'm going to do it manually. If you could, I'm going to do it like hands-on. If you can allow me to do that. So first of all, in theory, Git clone you are making. Sorry about that. Let's see. So let's say I just joined the team, right? So this is a repository, right? The repository is the folder that contains the files of source code, right? So let's say I've just joined the team. I've been hired, I passed the interview, yay, I'm now part of the team, and now they want me to add my changes or make my contributions to the source code, right? So this is the repository, but now I want it to be on my laptop so that I can make my changes and test them and then make contributions. So the first thing I want to do is, the way I do it, so the goal of this is cloning, right? So I get a link here to the repository. I've got a link to the repository, and what I want to do is I want to have a local copy of this repository or of the whole source code on my computer, so that I can then run or do my own, apply my own changes without having to have those changes applied to the actual main repository. So that's cloning, right? That's like it's like the main definition of what a clone is. With a clone, you are how do I say it? You just make another clone of the repo, but in this case, you make it locally on your computer. Let's think about clear command. No. Okay, so what I'm going to do is, I don't know if you can see can you see? You can see the command. So I'm going to run git clone. I copied the link, so I'm going to copy it here. So I'm going to run git clone so that I have this same. Actually, I already have this file in this. I'm going to just make another. Let me first get out of this directory. I'm going to make another folder. I'm going to enter that folder. Yeah, okay, so now I'm going to git clone. I want to get my own copy of that repository, right? So I'm now making a copy of my own repository. So that's cloning. You're just cloning the whole repository and having it on your PC. So now Git branch is now me making my own timeline, my own version of those changes. For example, so now if I do, so let me first enter that repo, cd git basics, GitHub basics. Yeah, so and then I see the branch which I'm on. So by default, you're on the master branch, right? But now if you want to like, so again, we have cloned, we now have the repo or the source code on our computer. So therefore we can now run the source code on our computer. We can even, we can run it without even having to connect to any internet because we have the source code on our computer, so we can just run it on our own PC. That's the main goal of cloning, right? Cloning is where you have the source code on your computer so that you can then apply your own changes. But now with branches, you can isolate changes. For example, now when I'm on the master branch, which is like the default branch, right? So let's say I want to make a fix for a bug, right? The first thing I have to do is I create a new branch just for that bug fix. So I'm going to call the branch bug fix branch. Again, forgive me for my names, but I'm trying here. Okay, so I'm going to just say git branch bug fix branch. So I run git branch again to see branches, and as you can see, I've created another branch called bug fix branch, and then I can go to that branch by running git switch bug fix branch, right? I run git branch again. I'm on the bug fix branch, right? So now let's say again I want to add a new feature to the repository, right? Let's say they want a new page, like a new posts page, right? So that's when I create another branch. Like say git branch. I'm going to call this new feature branch. I come back, git branch. I now have two branches of mine. I have one branch mainly for fixing a bug, another branch for adding a feature. So the goal of branches is isolating changes, right? And it's good because now when you're merging a branch or when you're adding changes to like a repository, you know where they've come from and you know what is being added to the repository because you're now putting them in different you have them in different branches. So I don't know if that answers your question or it just makes you more confused. So now if I want to add the new feature, I go to run git switch new feature branch, git branch. So I'm now in that branch, so I can do this. So now, you see it a lot. So you see it a lot better when you're working in teams. So you have people clone the repo on their own PCs to run them, and then they have different branches to isolate changes. If I want to make a bug fix, I make a bug fix on a bug fix branch. If I want to make a feature or add a new feature, I make a new feature on a new feature branch. Has that answered your question? Or
Yes,
somewhere?
thank you, sir. I do appreciate. Thank you. I think
Okay.
I'm a little bit clear now.
Okay, that's great. Any other questions before I move this to Alex? Okay, so no more questions, which is either a good sign or a bad sign, but I'm pretty sure it's a good sign. So I'll move this on to Alex. While Alex is presenting, I'll make sure to answer any question that will be shared in the chat. And yeah, all will be well. So thank you guys. I will stop sharing my screen and over to you, Alex.
Cool. Hello everyone.
Okay, so we having Alex Mkwizu now taking the second part of this workshop. Sorry, I was off a bit. So I assume there's no questions for Trevor, and let's have Alex now. Thank you, Alex. Welcome.
Cool. Hi everyone. My name is Alex Mkwizu, born and raised in Tanzania. For those who don't know what Tanzania is, it's in East Africa along the Indian Ocean. Yeah, so I do a lot of stuff, but my background is computer science. But currently, I am multidisciplinary creative artist that merges technology and storytelling. So that's the head path that I'm going at. But I have worked at UI and UX designing. I have done data science and machine learning, and I'm still doing it as part of consulting. But the key focus is leveraging technology and storytelling, mainly on interactive technologies such as gaming, XR technologies using Unity and Unreal Engine. Yeah, so that's it in a nutshell. Maybe I can share my LinkedIn profile. moment. While I really wish to have had time to know everyone, but if we can catch up through LinkedIn, yeah. So just to make this short and brief, I would like to make this very short and brief in manner in terms of communication and helping you understand the next phase. I believe Kato has done a great work in giving you the basics of operating Git and GitHub, because those two are quite different, but they're more like twins of some sort. Just to start with an icebreaker, who can tell me the difference between Git and GitHub? Anyone who wants to volunteer? Apart from you, Kato.
That's
Hello,
fine.
hello, can you hear me?
Yes, Hoffa.
Okay. When you say the difference between Git and GitHub, let's just say Git has to do with local access. Meanwhile, GitHub has to do with remote access. That's it.
Okay, James?
Okay, Pema. Hello, please can you hear me?
Yes, I can hear you.
Okay, Pema, aspect of Git and GitHub. No? With Git, it does with it helps us to send code to GitHub. So the GitHub is like a cloud storage where we use the Git. The Git give us the access to send the code to the GitHub.
Okay, thank you, James. I saw another hand. Was that Jan or someone else? Leopold. Leopold seems like King Leopold of the region. We learn in history. Leopold, you raise your hand. If you're speaking, we can hear you. Either, I'll move forward. So the key difference between Git and GitHub, Git is a version control tool, and there are multiple version control tools, but Git is the one that is mainstream, open source, and widely used. It has more of like become the standard of version controlling. However, when you go through the internet and search for version control softwares or tools, there are multiple of them. Some are closed source, others are open source. So funny story about Git. It was created by Linus Torvalds just out of frustration on using closed source version control tools, and he built it I think in a week or so. So that is Linus Torvalds, the person who created the Linux operating system. I mean the Linux kernel, which people have built different Linux distribution operating systems. So yeah. And the aim, I'll just reiterate, the aim of Git is to help everyone share code, but also track changes. So before Git or version control tools, what people used to do is, if you're working on the same project, I'll do my part, you'll do your part, and then you'll give me a flash or a hard drive, right? And then I'll plug it into my computer and then manually combine the code. That was the life back then. Or I email you the piece of code and then you manually combine, and then after combining, I send it back to you and then you run it. That was life back then, until Git came about. And then after Git came GitHub, the remote storage, right? So that's the short story about it. Funny enough, I wasn't able to create a fancy deck as how Kato created one. I'm really envy with what Kato did. But definitely, I'm more pro text based, right? So I just tried to put it into a Google document step by step, in which I'll be leading you through, but also you can get access to the document and try it by yourself. So what I'm gonna do, I am just gonna share this, make it open to everyone. By the way, you can comment on the meantime on the document, and if I see your comment, I can definitely answer it. Anyone with the link? Copy link. So I'll just share this document for those who maybe are using phones or something. Yeah. So ideal on my end, I have two main tasks is to communicate to you the complicated version of dealing with kids, which is dealing with conflicts, right? So I'll base from what Kato has already communicated. You have a single timeline, and then you create different branches, which creates multiple timelines. And then at a certain point of time, you want to bring everything to a single timeline because you're gonna use one single branch to launch or deploy your code base at the end of the day. And the reason we usually use branches, it is for 2 or 3 reasons. One is to allow you to work on different aspects without affecting the core code base. So assume maybe you're working on a payment software, right? And you're working on multiple features, right? So you already have a working branch, but you want to make changes. So instead of working on the same default branch, which has the code that you have deployed, you're gonna create a branch just to work on a particular feature and then test if it works. And if it does, then you're gonna merge it to the deployed code base, right? Branch by creating a pull request, and then someone will review it. If you have a person who reviews the code, and
Alex,
yes,
sorry for interrupting you. If you could please zoom in a bit, just to make the words a bit more visible.
okay. I also shared this to everyone so as everyone can access it, right?
Okay, cool.
Yeah.
Thank you.
So because some parts, when I zoom in, you just see a small part, not the whole document, ideally. So that's why I shared it so everyone can see it from their end. Yeah. So you are working on a particular feature, you have finished it, then you test it, and then you merge it to the default branch whereby you have deployed your code. That's it. So on my end, I'm tasked to demonstrate 1, fast forward, 2, non-fast forward merges, right? In terms of conflicting, I think Kato has done a very great work in showing how to create conflicts. I would try to make it the same thing. And now the key thing is understanding what does a fast forward merge mean and what does a non-fast forward merge mean. A fast forward merge, as the word says, is a fast forward. So you have two branches, branch A and branch B. A fast forward happens when the branch that you are in has the latest changes. while the branch in B has like past changes. So one branch is already forward in commits compared to the other one. Now this is challenging because these two branches need to be updated to the same point of time if you want to merge them, right? So if that doesn't happen, then you get a fast forward merge scenario. So simply, a fast forward merge happens when the current branch is directly ahead of the branch you're merging. Ideally, you use something like ahead. So hope that is clear. Any questions from that? Because these are the key things that you need to understand before move forward. Any questions on fast forward merge? None. And fast forward merge occurs when the branches have diverged. So what does this mean? Branches do diverge if the histories of these two branches are different. So this ideally happens when you work on multiple branches without syncing time to time. And everyone has a different comments and they're not syncing up. So at the end of the day, you have a non-fast forward merge. When you try to merge, Git will try to compare the histories. And when the histories do not match, Git will be confused. And then it will require a human to come in and say that these changes, I want to keep them as how they are, or this was a mistake. So I'll move now to the practical part. Moments. I'm sharing another screen. A moment. Okay. Yeah, hopefully you can see my screen. If you see my screen, thumbs up. Yeah. Let me try to extend this. Cool. So I think Kato has talked on using the GitHub CLI. Sadly, I like just using the terminal as how it is. I think it's more robust. That is my point of view. I think everyone has their own style of operating Git. Other people use the GitHub desktop. I think that is easier for most people who like are starters. But I think I really like to do everything from the terminal and not using a tool that it's not necessary to use. Sorry to say that, but it's also like personal choices, right? And yeah, so I'll just use the terminal as how it is. and please follow through. In your prior tutorials that you have gone through, you have learned on how to create a GitHub repository, right? That is for the remote, that you can create a GitHub repository, then clone it, and then start working from there, right? However, you can create a local Git repository, right? So to create a local Git repository, what you have to do is type git init, then the name of the repository. Make sure there are no spaces. So you're gonna type, oh shit. Why is this coming up again? So git init, let's call it, oh my god, sample. And using Git as the master, the initial branch's default branch name is easy to change to configure the initial branch to use an all hint of a new repository, which will suppress this warning call. So it has initiated my repository, but it has communicated that the default way uses master, like the default branch is called master. Now the reason why they're highlighting this in yellow as a warning is because the coding community came up with how do I put it? Like some of them were frustrated, why do we use master? And people were very violent on that because in some way or the other, it was linked to slavery, like master and the slave. So that is why they decided to change it to main. However, you can decide to stick with master. So they have told me I can choose to create the global default branch to master, or I can decide to change it to main. So I definitely want to change it to main. So definitely because I am pro people who think master is not a good one. Default branch main. Cool. So now I have a repository, a local repository named sample. But also when you do that process, it creates a new folder. And the folder will be called sample. So now if you navigate to the folder, you type cd and type the word sample, which is the folder. Now you have moved to that particular folder. Right? And there's nothing there. Then you can check for that. So these are terminal commands. I just want to check if there's this hidden folder called .git. So this hidden folder .git is the folder that stores, or it's a file that stores all of your Git data. So you might wonder, like, oh my God, how does Git remember all these things that I'm doing? All that history, all those commits that you have done, they are stored in .git. So if you decide to delete the .git file in any repository, then all of the history will be gone and you have to start from scratch. I see a hand. Someone raise the hand, please. Open your mic and talk.
No one raised. I don't know. No hand is up here.
Oh, okay, cool. So yeah, and that is really key. And so ideally, if you're using Git, never delete the .git file. To delete it, ideally using the terminal, you'll do terminal -r, then the .git, but definitely I won't delete it. Cool. Now, the next thing is to create a single file, which we're gonna use to recreate the fast forward merge scenario. And then we're gonna create another repository to create the non-fast forward merge scenario. To start with the fast forward merge scenario, we have already created our repository. We have already navigated to our repository, which this is the first step. The next step is creating a file. So you can create a file by coming here and type maybe sample.md, right? Just to create a markdown file. Or you can go to your terminal and say touch sample extra maybe .md. That also will create for you a file. Now the reason why I'm showing terminal commands, I really like terminal commands because it avoids me using a mouse or using the cursor to navigate and go and click the file button and then start writing in your file. I really like just to put my hands to the terminal or to the, like, that for me is the best experience I can have as a coder. Yeah. So we're gonna delete this one. Trash. Yeah. So you have your first file. So now, hey guys, we are learning Git today.
Please, can you help us to zoom in a bit?
Okay, let me. Okay. Now you can see. Now you can see. Yeah, so I'll try to zoom in and zoom out. So you have that. You're done. Control Shift this to get to your terminal. Now you have your terminal here. You've really created your first file, right? So we already know the commands. You git add, not a git repository or not. Okay. So ls. So I tried to do git add, but ideally it didn't respond because I am not into that folder. What I'll do is just cd, go to that directory, cd sample. Yes, I have the sample.md. Now I'll do git add, and git add adds that file, right? And then I can combine commands. So by using this, which is an operator and an operator, and then say git commit -m. Okay, so this is a cool thing that I've been told. It depends on how like you write your commits. So for this one, I'll just say add. So I choose add as a prefix, add, update, delete, or feature. It's things that you have to decide with your team on how you can use to create a commit, so as your commits can be much cleaner. So for me, I just put add, then put that mark and say created sample MD file. So in the commit message, try just to put something which is more reasonable and someone will understand. And if you have like a proper way on how to write your commits in that company, make sure you follow that, because the code reviewer will definitely look at it. Right. So I've added the file, I've committed the file, right? I don't have a remote repository, so there's no need to push. Everything is locally put. Now, we're gonna do the next step, which is creating another branch. So create another branch, you can use git switch or git checkout. So for this case, I'll use git checkout. So I'll type git checkout, then flag -b, and then I will name my branch. So I will call it branch 2. So when I do that, it will create a new branch and it will make me check out to that branch. So now I'm in branch 2. So if I look at the branches that I have by typing git branch, I have 2 branches, branch 2 and master. And to know which branch you are, if you type this code, you'll see that the output, the one that is in green, if you're using the basic terminal, is the one that you are operating on. Cool. So in this branch, I'll just create something in the same sample.md file. So I will do this. And I'll just delete that. Cool. Okay. All right. Move this up. I'll clear my terminal. So to clear a terminal, just type clear. If you're using a Mac or a Linux operating system, ideally if you're using a shell terminal. Shell terminal can be bash, can be ZSHL, or any related bash terminal. And now the same process, you can just navigate, say, can delete this, and then say update. Right, so I've made changes to my sample file in my branch 2. So if you say git branch, you can say branch 2. Now I will go back to my master branch because now I've made changes to my sample file in branch 2. Like maybe I was working on new features on all that. Now I'm going to my master branch so that I can merge and use my master branch to deploy. So git checkout master. Now I've switched to branch 2. To confirm that, you type git branch. You see that you're on master. All right. Now the next thing is trying to merge. So what you're gonna do is git merge feature. Here you say git right. So what we have done is basically fast forward. It is differently written here. All right. So the similar context whereby branch 2 was one step ahead compared to the master branch. So when I said that I want to merge, it had to combine the changes in branch 2 and the master branch, right, to create the fast forward scenario. So up to that point, we have finished the first phase of the tutorial, whereby you've been able to work on a fast forward scenario. I would welcome any room of questions before we move to the second scenario, which is creating a non-fast forward merge. Are there any questions? If there are no questions, can I have thumbs up, please? Oh, I only see Kato. Come on. Yes, I have questions. Guys, ask questions. Me,
Yeah, but if you have
while I was learning
questions,
this, I know these things are confusing, you know. And when you're trying to do it yourself later, and then you're confused, you just go to GitHub or to an LLM and ask those questions. But you have me now, so use me. So because I can give you something that an LLM can't, maybe.
yeah, we're all about
Hofa,
human-centeredness.
yeah.
Please ask your questions.
Hello,
You can raise your hand. Okay,
can you hear
Hofa.
me?
Yes.
Yes.
Yeah. I just want to get that point, that fast forward. What really, you were saying something, but I was cut off. What really led to the Git merge that gave you that fast forward? Something like that. I just want you to maybe a recap.
Okay. So you get a fast forward when one branch is ahead compared to another branch that you want to merge. So for instance, in branch A, we had a file called sample.md, which is a markdown file, which had a sentence. This was the initial branch, right? And then I created branch 2 with the same message. But I started working on branch 2. I deleted some code, I added some code, which basically is just a bunch of words. And then I added, and then I committed. Then I went back to the master branch, so as I can sync between the master branch and the branch 2. While syncing now, Git will check, do these branches have the same code base? It's either yes or no. If yes, is this branch that I'm trying to merge, is it ahead in terms of commits and changes, right? If yes, that is a fast forward merge. So it will match the code, syncing between the master branch and branch 2, and then it will tell you that this is a fast forward merge. It will show the number of lines created and the number of lines removed, plus any changes that have been put into that code base. So as you can see here, sample.md, there are 3 changes that have been made, 2 pluses, 1 minus. I have another hand from Eke.
Good evening, sir.
Hello.
Hello, good evening, sir.
Good evening.
Good evening, sir.
Good
Sir,
evening. Good
please, my
evening, Eke.
question is, My question is, now you have merged the branches. Does the second one still exist? Does it still stand on its own, or we have only one branch now? And if we have only one branch, what's the name is it going to take?
Okay. So when you merge, you're not deleting a branch. You're just syncing between one branch and the other. That's the work of the merging function in Git, right? However, you can decide when you merge, after merging, to delete the other branch, right? And depending on which branch you are, right? So if your core branch is the master branch, and then you have branch 2 which work on a particular feature, after merging, you can say that I want to delete this branch after merging. However, that's not the best coding practice or development practice. So what happens in the development process, in a proper development process, you're going to have multiple branches and the core branch, which you're going to use to deploy your code. And what happens is, after making changes on your side branch, you're going to commit your code, right? After committing, you're going to push it to the GitHub repository. After pushing it to the GitHub repository, you're going to create a pull request to the core branch, whereby someone who is tasked to review the code will review the code. If it actually makes sense and it doesn't break the changes in the core branch, then that person will approve the pull request and then merge. So in GitHub itself, there is a feature whereby it asks you, after approving the pull request and merging the two branches, do you want to delete the branch or not? If you want to delete the branch, right, it will reserve the branch which is your core. Hopefully that has answered your question. Awesome. Any other question?
Any questions? Okay, do you still have a question, or you've not lowered your hand? Any question? Ask your questions from branching and merging, or anything you've been confused about so far. This is time now to ask. Don't be scared. Ask. Yeah. So we could have a speed question round. I want to have a speed quiz round, but I don't even know. So I'm assuming everybody here understands so far. Do we understand? React if you've understood or if you've grabbed something from today. Okay. That's beautiful. So on that note, I want to do a speed quiz round, but I don't know. Should we do a speed quiz round? I don't know why that is coming to my head today. Should we? React if you want us to do like a speed quiz round to know if we want to do what we've said. Okay, Temba is reacting. Benjamin is reacting. So the others are not confident enough about what they've learned, or they want to play it safe. Okay, Leopold, do you want to say something?
Yes. So am I audible?
Okay. Yes.
Am I audible?
Yes, you're
Yes, you are.
audible. Leopold, Please do
think-
speak.
I think there might be a problem with his mic. Maybe you check your mic very well. Or
Okay.
your setting. Or you type. Yeah. So thank you guys for joining in.
So that is
Yeah.
yeah. So that is fast forward. There is none fast forward. So I'm not sure if we should also do that or we should end here.
Oh, we still have non-fast forward. Please continue then.
Yeah.
I think someone
Yeah.
dropped something. Okay. No. Okay,
Okay.
so let's continue, and then
Yeah.
we'd have the questions and possibly a speed quiz to know if you guys have understood. So continue. Thank you.
Cool. So now we'll move to non-fast forward. I will make it fast because now you're already acquainted to the first scenario, which is fast forward merge. Let me just zoom out. Okay, cool. So I'll just CD back here. All right, I will create another local repo. Yeah. Git init. Let's call it Joker. All right. So we're gonna have a Joker repository. So you navigate to the Joker repository. So now you have, I have the Joker repository. So I can come here. Oh, open folder. Open this one. Yep, Docker. Then I can decide to open my terminal. That and check git branch. It's not there. Right, you have that. Cool. Now you have a clean repository, everything. Now, as usual, you create a sample file. FD. Right. You have this. Right. Cool. As usual, you do a git add and git commit minus and sample. All right. So now we have committed our first file. So if you do git branch, you have only one branch there. As usual, to create another branch and checking out of that branch is git checkout minus B. I'm going to call this side. Oh, side branch. No, that's much better. So you have switched out to side branch. If you take your git branches again, you have the side branch, right? And your side branch now also has the same kind of code. So what we're gonna do is delete this and say, oh God, we are so done, right? Then you're gonna run the same kind of code. It's just here, max here. So what I've just done is changed the file into a different, there is nothing of the first file that is there present. Everything has already changed, right? And now you want to merge the two branches together, right? You have branch A, you have branch B. And now this round, we will be merging to the side branch, right? So just to confirm in the side branch, so git merge main. Yeah. So git check out main. You are on the main branch. So that is still fast forward. Okay. So let's do one more change. You're in the main branch. You've made, oh good, you're so done. Let's put 1, 2, 3. And then commit. And then git checkout side branch. And I have 1, 2, 1, 4, 1, 3. And we're gonna commit it again. We're gonna add another 1, 3. And then git merge main. Yes, correct. So the trick here on the first route, I did the same thing as on the fast forward merge, but to clearly have divergent histories, there has to be multiple commits that show that when Git is trying to merge those two files, that they have diverged in history. So as you can see now, we have a commit that is far ahead and a commit which is really far back. And that's not only the case, but they have two different histories. And the commits, the commit history tree of the first branch is different from the commit history tree of the second branch. And when this happens, that is when a non-fast forward happens. And then Git will be confused. And you'll see something like this, and then you're gonna decide to choose either to keep the current change, which is this, or allow the incoming change. So you can decide to do it here manually by deleting this, right? Like that, and this, right? Or you can choose to resolve in a mesh editor, which is more fancy. And you can decide to complete the merge or what so. Right? So you can decide to use the interface or you just delete it and then continue. The other way on how you can make this more visual, for those who love the terminal, very clear. Is being able to visualize that through your terminal. And you can use that, a specific command known as git log. So what you're gonna do is try to write the command which is git log one line graph. So when you type this, it shows all that has happened in your command line tool. So we had this particular commit hash in the side branch, and we had this main. And now we see that we had this single one and the other one diverged, right? And they came to merge at the end of the day at this point of the end here. Let me try to zoom. So this is for those people who really like to stick to the command line and be able to visualize everything. Or you can rely on UI tools. Yeah, you can rely on UI tools, which is the same thing, but more fancier. So yeah. So that's the last part, which is a non-fast forward merge. I'm pretty sure I've confused people on that. So I will allow room for questions and then we close it off. Any questions?
If you have any questions, raise your hand or drop it if you can't speak right now.
Okay.
Okay, sir. So my question is it's for the non-fast forward. The question is when before initially you had the fast forward, and when you did the same thing again, when you about to do the same thing again, it was showing you that you have a conflicting issue. Is it because you have already committed first and committed again, and that means you have a branch that is far ahead and the other one is lagging behind? Is that the reason why the thing was conflicting? Because initially you did the same thing initially, the other one was far ahead, the other one was still below, but you wanted to merge the thing and it was fast forwarded. So I don't really understand what's going on in this particular aspect.
Yeah. So yeah, I hear you. It's typically, you can say it's the same thing, but it's not. So for a fast forward, it's basically one step ahead. I think that is very important to put, one step ahead. But when you have multiple commits, whereby one branch is way far from the other, right? In the GitHub perspective, it's a totally different history, because Git will check what was the previous commit, and the previous commit, and the previous commit. Oh my God, I don't even see the last commit. Like after 3 commits, that's when I see a commit that is similar to the commit on this way, or on the other branch. So the Git will see there is definitely a different history here. Like this branch is too far ahead that I can't just accept. So that is when it says there's conflicts. And therefore, you will be asked to resolve those conflicts. That is the simplest way you can put it.
Oh, all right, all right. I really appreciate. Thank you very much. I think
Okay.
in this we are trying to tell us that for the fast forward is just a step ahead, why non-fast forward is multiple steps ahead.
Yeah, like the key thing here is different histories. When you're just one step ahead, it's definitely like, okay, I'm here, but this is our history. But when you have done multiple commits, Git will feel like, this is something different. Cool. Any more questions? If not, thank you very much for your time, guys. Appreciate it a lot. And all the best in your journey in learning Git and GitHub.
Okay. Thank you guys. So I'm assuming no more questions. Thank you. Let me even first of all, thank you, Trevor. For those that don't know, Trevor is a software engineer. He's passionate about open source technologies, and he's a GitHub campus expert. Um, for Alex Mkwizu, thank you so much. You guys saw how like these two people have broken down things with the patience. Like I don't know what the like GitHub campus experts program. I don't know if it's like how they, I don't know what they put in you guys' tea, like how you like broke it down, the patience, and this is just really lovely. How like yes, the patience to break everything down, to the beginner level, and also compiled with your years of experience. It's just been so beautiful to have you guys here, really educating, and would definitely love to have you guys more if we have more sessions and more campaigns. Like, so for those of you that don't know open source nest, we're here to make open source more accessible to everyday people, to Africans, to people who have felt locked out, and we're starting a GitHub workshop. And we're hoping that we're inspiring you to get your hands more dirty and to be more involved with open source contributions. Alex Mkwizu, he's a multidisciplinary artist, he's a data strategist, he's a software engineer. He operates at the intersection of storytelling, research, and technology. He works with virtual realities that educate and heal. He works with data-driven solutions. Wow, he designs experiences that connects people deeply with people and environments, especially across Africa. So you guys see, we brought like 2 top people to talk to you guys today, just for one day. So better be here tomorrow, next tomorrow, and on the last day, because we still have 3 more days before we wrap up this GitHub workshop, and then we dive more into the contribution workshops. So stay tuned and please share your experience, tag us, share this workshop to people, tell them about it, tell them about us. Our platforms, our WhatsApp and Discord is free to join. You don't need to apply, just join in. Everything is free and accessible. That's the whole point. So yeah, see you guys same time, 7 p.m. West African time. I don't know. I feel like we might need to even put the different time zones, because right now we just say West African time. But yeah, 7 p.m. West African time. Tomorrow we'll continue. And thank you so much, Alex and Trevor. It's been so lovely having you guys. This session is recorded. So yeah, thank you so much, you guys. Thank you. You guys, please help us to thank them. Yes, thank you.
Thank you everyone for your time and all the best. Bye.
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 Bye, Hofa. Bye.